Okay, let's see the program implementation of bubble sort in Java. So here is a class and a method. I'll just focus on the logic over here. So you can take the array as your R or A, whatever. So let's say this is your array, 15, 2, 3, 4, 20, or probably um, let's say it is 9. Okay, so now as you see that the length is 5, right? N is 5 or array length is 5. Okay, so as we saw, number of passes will be 4, which is n minus 1. So hence this loop is to have n minus 1 passes, right? So you can see that it goes from 0 to n minus 1, less than I is less than n minus 1, which means that it will, in this case, it will be I will go from 0 to 1, then 2, then only 3, because n minus 1 is 4, right? N minus 1 is 4 because the length is 5, so n minus 1 is 4, so we need only 4 iterations, and that's why when we do I is equal to 0 till less than n minus 1, it gives you 4 iterations. Okay, so the outer loop is for the iterations of the passes, so number of passes. So if the array length is 10, you will need only 9 passes. So that will be from I is equal to 0 till I less than n minus 1 or I less than you can say 9. So 0 to 8 is 9, right? Now so why one less pass we require? I'll just revise it. Because if the array has, let's say, 5 elements, then in the last pass or the fourth pass, the n minus 1th pass, the array will be sorted, because you're comparing 2 elements at once and you're swapping them, right? So that the last pass is not required, because in the last but one, it is already sorted. Last but one, I mean that one less than the number of elements in the array. In that pass only the whole array becomes sorted. Okay, you can just see it practically also by comparing. All right, so so that's why we need only n minus 1 passes. Now the outer loop of for is for passes which is 0 to n minus 1 less than n minus 1. Now here the internal or the inside for loop, where we are using for int j is equal to 0, j less than n minus I minus 1. Now why we are having this j value less than n minus I minus 1? Okay, let's see that. So j is 0, it starts with 0 only. So let's say if this is, I'll just put the array here once again. Okay, so this is a 0, this is a position. Okay, now in the first pass, so j is equal to 0, right? So j is equal to 0, you have to at position 0 you have to compare 0th element with the first element, right? So you compare 0 with the 0 plus 1, which is the first element, right? So now let's say if you're comparing with the 0 and 1, means these two elements, we're comparing these two, right? You will get this, because you have to swap. Fine, then you will compare these two, so you will again get the comparison, you will have to swap, so it will become 3 and 15. Then you compare these, and then you compare these. Okay, so so here your j is, so what is happening actually in the for the j in the first pass, you are doing 0 and 1 comparison, then you are doing 1 and 2, then you are doing 2 and then you are doing 2 and 3, then you are doing 3 and 4, right? You don't have to do 4 and 5, because there is no 5 here, because that is not existing only, correct? So how you calculate this, or how to make sure that it does not go till the here till end in the here and you get an error, the array out of bound error. That should not happen, right? So let's say here the I was 0, okay, and you were doing all these things, you were doing all these comparisons, 0 and 1, then 1 and 2, then 2 and 3, then 3 and 4, correct, because your j will, so yeah, you have to have a limit over here, right? How to do that? Now let's say I is 1, so you will again do from I becomes 1, right? So again this in the second pass you mean to say. So then now your j will go from which to which. So let's see that 0 and 1, because the last element is not sorted, you don't want to actually go there. So 0 and 1, then 1 and 2, and then 2 and 3. We don't need to have the third one, which is, or the fourth one rather, third and fourth. Why? Because the fourth element, or the not fourth, the position 4 or the last element is already sorted, so you don't need this much. So only your j should go from 0 till 2. Okay, so how to make sure this is happening? So that's how you get that the j limit is n minus I minus 1, which is 5 minus I. In the first case is 0 minus 1, which is 4, right? So less than 4 only you need. Then in the second case it is 0, I is 1. When I is 1, what j becomes? The limit of j becomes 5 minus 1 minus 1, which is 3. So j less than 3 means only till 2. Okay, you don't want to go to the last element in every pass. That's why you have to do this formula. You have to get through this formula. Okay, and then when you compare the adjacent elements here, you just swap them. So swapping can be done by using a temporary variable. You take a temporary variable, you assign it to the first value, then you insert the next value to the first element, and then you again make the next element as your temp. So that's how your swapping will happen. Okay, so now just to make you understand this part again, how this is happening. Okay, so let me just do that again. J is going from 0 till n minus I minus 1. How is that coming out? So you only want to go from, because a j cannot, if you go till the last, your j will become, when you are saying a j is greater than, when you're checking this condition, aj plus 1, right? If you have 4 and 5, then your array will be wrong. You cannot go to the actually the next element, which does not exist only. So your j should always stop at 1 before this. Okay, so when you are doing the first pass, in the first pass you don't have to in the 0, let's say 0 1 2 3 4, I is the number of passes, so you don't need this. Okay, 0 1 2 3, and the j should go from 0 till 3 only, because 3 and 4 will happen. The next time your j should be going from 0 till 2 only, because your fourth element is already done and you only need to have till 2, because 2 will be compared with 3. So only till 2 you have to go. Then next time you have to go on from 0 to 1, and the next time only the 0th element will be there, right? So how you can see now, you can just see the relation that this limit is cleared. So you can just say that it's j less than n minus I minus 1, or you can also say j less than equal to, n minus I minus 2, right? Both are same. But so just to keep it simple, let's not go into this, we'll just see this one, n minus I minus 1. So 5 minus 0 minus 1, which is 4. So this is less than 4 is still 3. Then again n minus I minus 1, which is 5 minus 1 minus 1, which is 3. 5 minus 2 is 3. So less than 3 only will go till 2, and so on. Okay, so that makes your bubble sort. This is the only code which you need to understand, and then you are done with the bubble sort.